So now we'll talk about what are forces. So in classical mechanics, an object with known physical properties is placed on any initial location moving with an initial velocity. We know, or we can measure, all of the interactions of this object with its environment, that is, all of the objects that are surrounding it. And we can predict the subsequent motion of that object. That is, we can predict its position and velocity at all future times. So basically, the classical problem is find x as a function of t and then calculate velocity and acceleration known from it. In general, we can generalize this by a three-dimensional vector having components x, y, and z, as we talked about in the last chapter. So what is force? The interaction of a body with its environment is described in terms of force, which is denoted by F. All human activity involves forces in some means or another. You just sitting on this chair involves forces. A force can be described as a push or a pull in a certain direction, which means if it is a push or a pull and it has a direction associated with it, then it has to be a vector quantity. So forces are described by using vectors. For every force, we must specify a direction on which it acts, and the forces have to be combined by using the rules of vector additions. Head to tail rule, for example. Now, what is the cause of a force? Each force exerted on an object is caused by a particular body in its environment. For example, pushing force on the crate by a worker, the frictional force on the crate by the floor, or gravitational force on the crate by the earth. So, when analyzing forces in a problem, please be very careful to describe each force on which acts on the body and the body in the environment that is responsible for the force. So how can a force be measured? Well, one simple way of doing this is by a spring scale. By hanging the masses on a spring, we find that the stretch of the spring is proportional to the applied force. So as you keep increasing the mass more and more, the spring will stretch more and more. Another important thing to remember is that the SI units of force are newtons. We will talk about this again. Net force. The net force is the vector sum of all the forces that are acting on the body. So for example, net force can be all of the different kinds of forces that are acting on it. For example, while you're sitting here, force of gravity is acting on it. There's friction present between you and the chair that you're sitting in, and so on and so forth.